All right, so how is everyone today? Good, bad, tired? Or just like put a reaction in chat. Put a thumbs up if you're good, bad, or whatnot. All right, I see a couple thumbs down. So, all right. So today we'll be doing SAT math again. Last week was ACT science plus just like extra ACT math that isn't on SAT math. Today will be just SAT math. Of course, you can ask any questions you had about last week's lesson, and I'll be happy to answer them. But let's just get started. So table data. What are like table data problems on the SAT? So on the SAT, table data problems ask you to use two-way frequency tables to calculate proportions or probabilities. Two-way frequency tables include two qualitative variables, one represented by the rows and the other by columns. For example, the table below summarizes the concert attendance of students in Dr. Rommel and Dr. Yukovic's classes. The two variables are class and concert attendance. So you have, I guess, a table where so 17 people from Dr. Rommel's class attended the concert, 23 from Dr. Yukovic's class attended the concert, and so on. And it just gives you data about, I guess, a situation. So how do you read two-way frequency tables? So the biggest challenge of data table problems is understanding what the question's asking for. So for some of the values, let's just talk about some of the values in the table below. So as I said, let me just get my annotation tool up. So as I said here, this is the amount of people in Dr. Rommel's class that attended the concert. And this is the amount of people in Dr. Yukovic's class who attended the concert. And the total number of them is the total number of students in total number of students who attended the concert. Same for this one. This number tells us how many people in Dr. Rommel's class did not attend the concert. Same with the 10 here. And this tells us the total number of people who didn't attend the concert. And then these numbers all the way at the end tell us how many people are in Dr. Rommel's class. Same with Dr. Yukovic's class. And then the total number of people in both Dr. Rommel and Dr. Yukovic's class, as well as the total number of people who attended the concert and didn't attend the concert. So yeah. So here's just like a small data, I guess, practice problem. Again, this is just reading the data table and telling us a probability. Remember, the probability needs the part and the whole. So once you do find, I guess, a certain part, you need to find what it's out of, or like how much of the whole it is. So yeah, I'll give you guys a minute to do this. So for the people who are asking for a single location with all of the slides, I talked about it with the people who came earlier, but I have not made one yet, but people were asking for it. So I'll make one by next week and share it with you guys then. Also, yeah, just like put your answer in the chat after you get it, so I know if people get the answer, I guess, or if I should go back and explain it about why it isn't a certain answer. All right, so for the person who gave a decimal, I would say don't use a decimal because the answer goes into multiple different places. I mean, the decimal version of the answer has a bunch of digits, and the SAT doesn't usually give that. just use the actual number and don't use the decimal form. So yeah, this question is pretty easy. It's asking us what's the probability that a selected student does not play video games and doesn't watch gaming live streams. So you have the, I guess, section of people that don't play video games. So it has to be within this. Oops. And then you have the section of people who don't watch live streams. So it has to be within this. Therefore, the answer is 39. But remember, again, you have to make it part over whole. So the whole is 151 here. And that is the answer. I would not recommend probably ever doing your answer in percentages or decimal points unless the question asks, simply because usually the answer doesn't use decimal places or percentages. And it's a lot harder to put in some decimal places, some decimals into the free response section. And so this problem allows for a silly mistake of just putting the number 39, because again, you're going to be in a rush during the SAT. You're not going to have time. This is not a calc question simply because you don't need to calculate the percentages and the decimal points, the decimal places, I guess. So for this question, I would say the main thing is to read the problem, and it says the probability. So you're going to need a part over whole. So when you do have these problems, don't rush and just say, oh, it's 39. That's the number of people who don't play video games and don't watch gaming live streams. Don't just put 39, read the problem and write it out of, I guess, part over whole. So scatterplots. What are scatterplots? A scatterplot displays data about two variables as a set of points in the XY plane. Each axis of the plane usually represents a variable in a real-world scenario. So this could be like time versus distance for a car traveling somewhere, or it could be time over like depth in water when you're diving into the ocean or whatnot. And it's just scatterplots are like a relationship between two different variables at a certain points of time, I guess. It doesn't really even need to be time. It could be other stuff. So what is the line of best fit? So while each point in a scatterplot represents a specific observation, the line of best fit describes the general trend based on all of the points. So basically it's like the average, you could say it's like the average rate of change, really. No, it's not that. It's basically a line that tells you, that predicts what a value would be in a certain location based on all of the points given overall. So for a given data point, we expect to see a difference between its y value and the y value predicted by the line of best fit. These differences are used for more advanced statistical analysis. And for the SAT, you don't need that. You only need to calculate the difference. We can also interpret the slope and the y-intercept of the line of best fit the same way we interpret line graphs. The slope represents a constant rate of change, and the y-intercept represents an initial value. So here's a practice problem. I'll give you guys a minute to do this. Just put your answer in the chat, and I'll do it after that minute. Again, if you guys have any questions, don't hesitate to raise your hand so I can clarify it, I guess. All right, so I see two different answers from everyone who responded. I would say roughly maybe three out of 7 people. So out of the people who did answer, roughly, I'd say 30 to 40% of you got it wrong. Do you guys want an extra minute to do this problem? Or do you guys want me to explain it? Just put it in the chat if you want me to explain it, or give you guys an extra minute to do it. All right, so you guys want me to explain it? So the widest, so it's asking for which of the following statements about the widest picture frame is true. And the widest picture frame is 25 inches wide, and it's 34 inches tall. That would be right here. This is the widest picture frame, and it's 25 inches tall, and 25 inches wide and 34 inches tall. And the line of best fit passes through the point 25 to 30. So it's roughly around 4 higher. Therefore, it would be A, because the line of best fit is actually 4 under what the actual height of the picture frame is. And therefore, the height of the picture frame is 4 inches higher than the height predicted by the line of best fit. Do you guys understand why it's A and not B? B is by far, I guess, the most incorrect answer, the most chosen incorrect answer. Do you guys understand why it's A and not B? Or should I explain it again? Right. Looks like everyone understood why it's A and not B. Do you guys want to tell me why you got B instead of A? Anyone? No? All right. Here is another practice problem. I'll give you guys a minute to do this one. Hopefully more of you got it right than the last time. Last one. Okay, yeah. So I see 2 reasons why. So you guys didn't look at the scale on the y-axis, and all right, so both of those were, I'm gonna guess, silly mistakes. For the people who told me why they got the previous one wrong, looks like both of those were silly mistakes. Be careful to like read the problem carefully beforehand, and like look at the graph at all points, I guess. Look at all of the information presented by the graph before having an answer. All right, once you guys get this answer to this question, just put it in the chat. And again, I hope more people get it right this time than last time. All right, do you guys need more time, or should I start explaining it? You guys still need more time, or do you guys want me to explain it? Just like put it in the chat so I know. All right. So for this problem, it's asking us. So I'll just read the problem out. A panel is rating different kinds of potato chips. The scatter plot above shows the relationship between their average rating and the price of the chips. The line of best fit for the data is also shown. According to the line of best fit, which of the following is closest to the predicted increase in average rating for every $10 increase in price? So the line of best fit passes through the points of 1, 0 here and 2, 5 right here. So, and it looks like it passes through those points. So we can get the slope from these 2 points because you could do 5 minus 0 over 2 minus 1 x2 minus x1 over y2 minus, oh no, I did that backwards. y2 minus y1 over x2 minus x1. And that's how you get the slope for something given 2 points. So with that, you get the slope is 5. And that means the line of best fit predicts a 5-point increase, 5-point upward trend for every $1 increase. So, or 0.5 increase for every 1/10 of a dollar. Whatever, 1/10 of a dollar. That's why, because you just divide this by 10 and you divide this by 10 to get these two. So therefore the answer is B. For the people who got it wrong, do you guys understand why it's B? And would you like to explain why you got it wrong? Or is it just like silly mistakes? Because roughly 50% of you got it wrong, at least of the people who answered it. So I got the 5 minus 0 and the 2 minus 1 because I'm trying to calculate the slope of the line of best fit, which is this thing. Whoops. Which is this thing. And since I do know 2 points, 0, 1, 0, 1, 0, 1, 0, and 2, 5, because it passes through these 2 points, the points I circled, I can use the formula of getting slope, y2 minus y1 over x2 minus x1, which is basically 5 minus 0 over 2 minus 1 to get 5. And that gives me the slope of the line of best fit for every 1 increase in dollar. So you have the 5-point increase for every $1, and then you divide both by 10 to get 0.5 increase for every 1/10 of a dollar. Do you understand, Bindu? I hope I pronounced that right. All right. Anyone else confused about why I got what I did? No? All right. So key features of graphs. So what are key features of graphs problem on the SAT? So key features of graphs problems asks us to interpret graphs or create graphs based on given information. And the 2 most common graph types on the SAT are bar graphs and line graphs. So I'm going to also include histograms simply because those, I would say, are also really popular for questions, these types of questions. So bar graphs, on a bar graph, the sizes of the bars are related to the size of the quantities. The larger a quantity is, the taller or longer the bar representing it is. Dot plots use dots to represent the frequency which particular values occur. So dot plots are usually used for low, easily countable frequencies because it is impractical to draw or count many dots. So for dot plots, it's like something like this. You have like dots. And that would continue for like other ones. 1 sec. I think I forgot to remove permissions for something. 1 sec. There. And yeah, it just continues like that, depending on how many of your ones you have. So like say you have 1, 2, 3, and then it goes blah, blah, blah of how many ever something there is. So then histograms use bars to represent the frequency at which a range of values occurs. And histograms are useful because it's often impractical to list every possible value independently. So histograms are basically like, I guess, bar graphs, because they're really similar. They use, so the more there is of something, the higher it goes. However, histograms do a range of values versus bar graphs, I guess, number of a specific thing. If you guys understand that, yeah. So another type of graph that's pretty popular for the SAT to use are line graphs. So what are line graphs? Line graphs usually show how quantities change over time, and the SAT will most often ask us to do the following. It will ask us to identify values on a graph and use them in calculations, determine whether the graph is increasing or decreasing, and we might be asked about a specific interval or the entire graph. It depends on the problem. Determine when the rate of change is the highest or lowest. Higher rate of change correspond with steeper sections of the graph, and lower rate of change correspond with shallower sections of the graph. So I have a little graph on the side here. Don't mind the numbers, they don't really matter for this case. So this section of the graph would be decreasing. This section would be increasing. This section would be steeper than this section, which is shallower, I guess, shallower, because it's increasing at a much faster rate than this thing is decreasing. So how do you draw line graphs based on verbal descriptions? So to translate a sequence of events onto a line graph, so on the SAT, in addition to reading line graphs, we may be asked to select a line graph that represents a given scenario. These questions tend to be about the correct order of events and the general change of direction. And the ASCIIs of the graphs are often represented without exact values. So what are some key phrases to look out for? So there's like a table over here, which has a bunch of phrases and I guess the equivalent of them on a graph. So for increases, rises, and grows, you have like an upward trend, which means really just it goes up. Decreases, drops, and declines, which means downward trend, so drops, it just goes down. Remains constant, stops, stays the same. That would be just like a flat line, which doesn't increase or decrease. I drew that bad. It's like just a straight line. Slowly, gradually, so you have a shallow slope. It's like it's increasing or decreasing, but like at a very slow rate. Rapidly, quickly means it's increasing really fast and decreasing really fast or decreasing really fast. So here is, I guess, a graph practice problem for you guys to do. I'll give you guys a minute to do this one. And yeah, just put your answer in the chat after you get it, so I know if you guys got it right or wrong. All right, it seems like everyone who's answered has got it right. I'm gonna hope the person who put it latest mistyped that. But yeah. So for this problem, the x-axis of the graph shows the number of years since 2014, and since 2015 is 1 year after 2014, and 2019 is 5 years since 2014. So the graph contains the points 1, 5, and 5, 15 right here, and which means that Paulina owned 5 video games at 2005. So 2015 is 5 games, 5 Gs. And in 2019, she had 15 trees. So you do VG video games. 2015 is 5. VG 2019 is 5 over 15 because you want the average. I guess just like the average line of best fit, really. So you have that. So that's 1 over 3. And that is just our answer because that is what it is, really. It's not even, I said that wrong. So you want the number of games in relation to the number of games in 2019. So you have 5 games in 2015 over 15 games in 2019. So it's just 1/3. All right. Any questions? Again, this is a free response. So the 2 ways of putting this would be 1/3 or 0.333 is also accepted. You don't need to signify just infinite because there's not an infinite symbol on the SAT free response section. But either one of these is a valid way of writing it for the answer. All right. Linear and exponential growth. So, one sec for the people who are asking for today's slides. I had posted them at the beginning of class, but for the people who joined after that, here is today's slides. Yeah. So what are linear and exponential growth problems? So consider the following. Alphonse and Becca both have 100 followers on a social media platform. And over the next 12 months, Alphonse's number of followers increases by 10 every month, and Becca's number of followers increases by 10% every month. So linear and exponential growth problems are all about understanding and comparing scenarios like the one above. So Alphonse's is a linear increase because it's increasing by the same amount every month for 12 months, while Becca's is an exponential increase because the amount that her social media, the number of social media followers that she has increases by a greater amount every single year, every single month. So there's not a constant amount that it increases by, while Alphonse's increases by a constant amount every month. So writing equations based on tables. So when we're given a table of XY values for a given change in X, if the change in Y can be represented by repeatedly adding the same value, then the relationship is best modeled by a linear equation. As I said, a linear equation is when the same number is added repeatedly. On the other hand, for exponential equations, as the next point states, if the change in Y can be represented by repeatedly multiplying by the same value, then the relationship is best modeled by an exponential equation. So instead of adding a same, I guess, number, you're multiplying instead by a certain number. Doesn't really matter what number. That's when you have exponential versus linear. So once we determine the correct type of equation to use, we can write the equation by using our knowledge of linear and exponential equations. So the simple equation y equals mx plus b is a linear equation. Again, here's like a small graph of linear versus exponential. So this is linear, lin, and this is exponential. Use something like this. So for y equals mx plus b, m is the number repeatedly added or the slope, and b is the initial value, so the number that it starts off at. And then for exponential equations, you have y equals to a times b to the x. So b is the number repeatedly multiplied, or like it's also called the common factor or common ratio. And a is the initial value, or like the y-intercept of the curve when the equation is graphed in the xy plane. So what are some common phrases to look out for? On the SAT, all linear and exponential growth questions are multiple choice. So you won't really have any questions of that type in the free response. And you're usually asked to like choose the correct description of a scenario from 2 linear and 2 exponential descriptions. Choose the correct modeling equation for a scenario from 2 linear and 2 exponential equations. And this means that like we have to figure out whether a relationship is linear or exponential before I'm going to reset it. So If we find out whether a scenario is exponential or linear, you immediately get rid of 2 of the 4 answer choices. So that is always a help. And after that, like if your choices are descriptions, we need to figure out whether the relationship is increasing or decreasing. And if the choices are models, we need to use our knowledge of like linear and exponential word problems to find the equation that includes like the right values. So the table below lists some like common phrases in linear and exponential growth problems and how to interpret them. Again, in these like phrases, C is like C is constant. So phrase changes, increases or decreases at a constant rate. That almost always means linear. Changes by C per unit of time. That's linear. Changes by C percent of the current value per unit of time. That means exponential. Changes by C percent of the initial value per unit of time. That means linear. This don't be confused by this here, because of the initial value, because the initial value is constant and doesn't change. And taking C percent of a number that doesn't change always results in the same number because that number doesn't change. And so it always increases by the same number. It changes by a factor of C, for example, like halves, doubles per unit of time. That means they almost always means exponential. Any questions about this slide? No? All right. So here is, I guess, a practice problem. Yeah, just like match each of the four scenarios to their appropriate description. They are not in the right order, and you will need to shift them around. And I guess we'll just call these this. So when you guys give your answer in the chat, this will be A, B, C, D. This is 1, 2, 3, 4. This is related to this, this. And when you give your answer, do like A equals to 1, B equals to 3, C equals to 2, and D equals to like 4 or whatnot. So I could tell what you guys got, and you don't have to type in the ridiculous amount of stuff there, I guess. And yeah, just like put your answer in the chat after you do it. Also go to the slides if you guys want, if you don't remember what the I guess graph with all of the different words to what they mean is. I'll give you guys another 30 seconds to do this one. Again, just put your answer in the chat after you get whatever you get. All right. So for the people who did answer it in the chat, most of you got it right. Some of you got two of them mixed around. So here I'll just draw lines between which is which. So you have increasing linear is plant height increases. I believe everyone who answered it got it right. Decreasing linear is George has $200. Increasing exponential is for a savings account, and decreasing exponential. Oops, I did that backwards. I wrote that back wrong. Undo. Increasing exponential is this, and decreasing exponential is this. So the two that people did get wrong were decreasing linear and I believe decreasing exponential. And remember, if it increases or decreases by a certain amount, then that's linear. If it increases or decreases by an amount that changes every so often, that's exponential. Anyone have any questions about why something is something? No? All right. So any questions about what we've done so far before we get into more practice problems? Today was a bit longer of, I guess, a lecture-ish day. So yeah. No questions? All right. I'll give you guys 2 minutes to do this. Again, if you have any questions at all, just like message, just like ask it in the chat and I'll answer them. I'll give you guys another 20 seconds to do this. Well, it looks like everyone who's done it has got it right. 1 second. All right. So everyone who's done it has got it right. Actually, no, wait. I take that back. So most of you have got it right. So for this one, the answer is A, because at x equals to 10, which is right here, y is 3, and the actual data point is 2. So the actual data point, the value of the data point is 1 less than the y value predicted by the line of best fit, because the line of best fit predicted 3, but the actual data point is 2. So you have 1. Therefore, the answer is A. Any questions? So for the people who got B, do you guys want to explain why, or was it just a silly mistake? All right. I'll give you guys 2 minutes to do this one. right? Looks like most of the people who've answered it have got it right. So for the people who haven't answered it yet, I will do it right now. So in the scatter plot, each individual point represents like a recorded heart rate at a given swim time. And the line of best fit provides the predicted heart rate for a set of times. And the question asks us to determine the difference between the predicted heart rate at 34 and the actual heart rate at 34 minutes. So we can see at like 34 minutes, Michael's actual recorded heart rate was like around 148-ish. It's somewhere there at 34 minutes. So 148 is right here. And the line of best fits predicts it at like 150. So the difference is 2. The answer is B. And it looks like all of you got it right. So there's no point in me explaining it again, unless someone wants me to. Does anyone want me to explain it more or no? All right. I'll give you guys 2 minutes to do this one. Again, just put your answer in the chat after you finish. All right, so this problem is pretty similar to what we just did for the last two. Do you guys want me to explain it? Because it looks like everybody's got it right. Do you guys want me to explain this or just move on to the next one? All right, so people were asking me to explain it. So I'll explain it pretty quickly because this is the same as before. So the figure above like shows the percent of people who are smoking in the US from 1980 to 2000, and a line of best fit also is given. So based on the line of best fit, which is the following, is the closest to the predicted percentage who are smokers in 1981. So you want years since 1980. So 1 year is right here. If you go all the way up, I'm drawing a really bad straight line, but that is around 31, 32. That's around 33%. Therefore, the answer is D. Do you understand it, Jay? Why it's D? All right. I'll give you guys 2 minutes to do this one. Should be pretty easy. All right, looks like, again, every single person who's answered it has got it correct. Do you guys want me to explain why? Or, okay, no, never mind. There's people who got it wrong. All right, do you guys want another minute to do this, or should I start explaining it now? All right, I'm just gonna explain it. So Norman was 52 centimeters long when he was born, and over the next 6 months, his length grew at a rate of 25 centimeters a month. If f of t is Norman's length in centimeters t months after his birth, which is the following statements, best describes the function f. So the answer to this one is B. And the reason for that is every month he's growing at a constant rate of 2.5 centimeters. So it's not the rate he's growing at is not increasing or decreasing at all. The rate he's growing at is stable and stays the same. Therefore, the answer is B, because an increasing linear function is when the rate of change is same but positive, and that it is in this case. So you have B for that one. I'll give you guys 2 minutes to do this one. Okay, just put your answer in the chat after you've answered it. So I will say a lot of you have gotten this one wrong so far. Do you guys want another minute to do this, or should I just do it now? Do you guys want me to do it now? Because or do you guys still need more time? Right, looks like people still need it. Still need some more time. Do you guys still need more time, or should I just do it for the people who asked me for more time before? All right. So first thing I will say is most of you got tricked by the percentage sign is what I'm guessing when you got solved. All right. So first thing is, even though the question contains the percentage here, it also states that the passerby take the free cookies at a constant rate. So this alone should clue you in that it's linear. And if you look at like when you do look at like the 50%, it refers to the amount of cookies given away at a specific time. It does not imply that the 50% of cookies is gone every 2 hours. So you can immediately eliminate C and D, which C of all the answer choices C was the second most chosen, and it's just straight up just wrong. And then so you eliminate C and D, and that leaves us with choices A and B. So 50% of 600 is 300. So we could say that 300 cookies are given away at a constant rate in 2 hours. So, or at a rate of like around 300 over 2, because 2 hours, 300 cookies. So equals to 100 cookies, 150 cookies per hour. So you can express the rate as minus 150 per hour. And that alone should just give us that it's A. And for the rate of negative 150 and the initial value of 600, and you could write the C, the number of cookies remaining. So you have 150H plus 600. So, and if you rewrite that, that's literally just 600 minus 150H. So the people who chose C, do you guys understand why? And I'm guessing you guys just looked at the percentage sign and went immediately like, oh, this is an exponential problem versus a linear problem. So yeah, again, for these types of questions, I will say reading it really carefully is the best solution to why you got it wrong if you did choose exponential over linear. So does everyone understand why it's A, not B, C, or D? All right. 1 second. Just erasing all this. We'll give you guys 2 minutes to do this one. Again, just put your answer in the chat after you get it, so I can tell who got it right and wrong, and maybe even assume why someone got it right or wrong. Depends on which one you guys put. Roughly half of you've got it right so far. The other half have got it wrong. Right, looks like most of the people who just answered have got it right. So I'm going to assume that the people who got it wrong either rushed and didn't read the whole problem entirely, or just guessed. I'm not sure. So do you guys want me to do this problem now, or do you guys still need more time? Just answer now if you want me to do it now, or more time if you need more time. All right, so for this problem, the answer is C. So most of you have got that right. So the reason it's C is, first thing you can tell is it's exponential, because every time you multiply, every time you go like 1x, if you multiply y by 2 times 2 times 2 times 2. So you know it's exponential because it's always multiplying by something versus adding by something. So you take out A and you take out B. So now you have either C or D. And here you can immediately take out D because it suggests that there's a factor of 5 here versus a factor of 2. So you take out D and you're left with C. And you can confirm it, the initial point, by using the point 1 comma 5. And if, oh my God, I think broke all of a sudden. So you have 1 comma 5 is your thing. So, and we know if x decreases by 1 to 0, then y must divide by 2. And that's 2.5 or 5/2 for 0, which is your y-intercept, and which is also what c is. Any questions? No? All right. Here is a problem. I'll give you guys 2 minutes to do this one while I go find an extra and especially difficult problem because we went a lot faster than I thought we would. Again, just put your answer in the chat after you get it. While you guys do that, you just give me a second so I find some extra practice problems for you guys. One second. All right, so for this problem, it looks like everyone has got it right. The answer is B. One second, I'm just trying to get something real quick. Okay, so the answer is B. Do you guys want me to explain why? It looks like everyone has got it right. Yeah, it looks like everyone has got it right for this one. No explanation. All right. Let me just put in the new question that I just got off online. Insert it. Oops. All right. So I got this off Khan Academy. Question at level 4. There. Actually, no, we didn't even need that. There. Just do that problem for, I guess, just take 2 minutes to do this problem. While I try to do it myself so I can explain it to you guys. So Again, this is probably a calculator question. So you can use your calculator. Or actually, no, wait. It might not be. It's just math and just guesstimate or choose whichever is closest. All right, have most. Do you guys need more time or? Looks like some of you have answered. For the people who did ask for more time, do you guys still need time? I will say some of you have gotten it wrong. Most of you have got it right. All right, so for this problem, simplest way of doing this, add these two numbers together and you get, so what it's asking us is in 2001, so just ignore this section. What is the probability that a group of fly will be found in either one of these two instead out of all three of these? So after you add those two together, you get 5285. And the overall, I guess, frequency of sample flies is 7925. And then you divide both of these because you want the probability of it appearing in these two places versus all three of these. And you get around 67%. So C. Does everyone understand why it's C and not some other number? Yeah, all right. So another question. Just find it real quick. While I do that, just like if you guys have any questions, just put it in the chat while I find another question. Right. Never mind, I have a question now. All right. This is a linear and exponential growth question. I'll give you guys 2 minutes to do this one. Again, just put your answer in the chat after you get it, so I know what you guys got. This one is a harder question than the other ones that we've done. So I understand if it takes you guys a bit longer. So I'll ask in like another minute. If you guys need more time, just say it if you do. Again, just put your answer in the chat after you finish. I will say almost all of you have got this wrong so far. You might want to check what you guys did to get whatever answer you've gotten. For the people who did answer so far. Maybe 2 out of the 10 people who did answer so far have got it right. All right, do you guys want me to explain it now, or do you still need more time? Again, don't be afraid to ask for more time. It doesn't really matter since this isn't the actual SAT, and you are allowed to take more time than you would usually need to go on the SAT. All right, you guys want me to explain it now, or still more time? Again, just like say it in chat if you want me to explain or not. No. All right, so this question is a lot trickier than the ones that we just did. So first thing we do, if my tool would work. All right. So all the equations give the correct value of f for k equals to 0. So you can't just plug in whatever k of 0 is and get the right answer. So the linear equations have graphs that are straight lines, and the data points don't form straight lines, because if you were to just like have a sketch for 0, 1, 2, no, 0, 12, 24, 36, 48, 6, 48. I can't draw. I'm just gonna undo this all. Whoops. Undo. All right, so 12, 24, 3648. So you have that. So the graph is not just a straight line. It's like, so you start off here and you go here, and then it slightly more than doubles. Or wait. Oh, wait. I said this wrong. So the data points don't form a straight line. And so neither of these answers are correct. As I was, if you do somehow graph it, it's going to somehow end up like this or whatnot instead of like this. So both the linear answers are not correct, which means that C won't work and D won't work. So now you're down to A and B. And so of the two exponential equations, let me just erase this. Of the two exponential equations, A and B, the first one gets larger too quickly, and you can see this by plugging in any other integer other than 0 for k. And for the second one, the frequency doubles every time we move 12 to the right, because every 12 we have to double versus every one we double. So the answer is B, because we want to double every time we get to 12, every 12 steps, instead of every one step for A. Do you guys understand why it's B now, or should I explain it again? Yes for explain it again, or yes, you understand if you understand what I explained. All right. So yeah, that's really it. As you could tell, I was not prepared for us to go that fast for the other problems, and I didn't really prepare much else. So I'll end class early today. So for next class, just search up more information about the ACT science section mostly, and just like what else is on the ACT math section versus instead of like the SAT math section, which contains fewer subjects in the ACT math section. And next class, we'll be doing parts of scientific investigation, interpretation of data, and matrices. So yeah, that's really it. Do you guys have any questions about what we did today? No? Then that's all for today's class. Have a nice day, everyone, I guess. Let me just stop sharing this.